Welcome to the deep dive. So imagine you've got two glaucoma patients, right? Both have an identical IOP of, say, 16.
Which, we see every single day in the clinic.
Exactly, but one is losing their visual field significantly faster than the other. I mean, why is that? Well, a new paper in the February 2026 issue of Ophthalmology from Montesano, Garway-Heath and Gazzard over at Moorfields might actually explain this paradox. Honestly, this paper brings the data many of us have been waiting for.
Yeah, it really does. Because we're looking at the 6-year data from the LiGHT trial. And, if you're managing glaucoma daily, you obviously already know the LiGHT context.
Right, the baseline stuff.
Exactly. We already knew that starting newly diagnosed patients on SLT rather than drops was cost-effective.
Yeah.
We knew it left 74% of them completely drop-free early on. But the massive pending question was always, does SLT actually preserve the visual field better?
And to answer that, standard regression just doesn't cut it. Because these are newly diagnosed patients, so we know the parametric learning effect is going to create this artificial upward bump on their first few fields.
Right. They just get better at taking the test over time.
Yeah, and that positive bias artificially flattens the progression slope. So to fix this, the investigators used a Bayesian linear mixed model to mathematically isolate that specific learning curve from the true disease progression.
Which is just a brilliant approach, honestly. It's like trying to clock a runner's true speed while they're running on a moving walkway.
Oh, that's a great analogy.
Yeah, the Bayesian model basically acts as a mathematical treadmill.
Mm.
It subtracts the artificial forward momentum of their learning so you can measure their actual physical pace.
So once that mathematical noise was filtered out, the true trajectory became incredibly obvious. Visual field progression was 30% slower in the SLT arm.
30%? I mean, that's huge.
Right. We are looking at minus 0.26 decibels per year for SLT compared to minus 0.37 decibels per year for drops. And that's with a p-value of 0.007. Plus, the SLT group reached their target IOP more than 3 times faster.
Wait, 3 times?
Yeah, a median of 0.69 months versus 2.24 months.
Wow. And, the gap actually widens even further when you look at the mean deviation and especially the pattern deviation. The drops arm had significantly more cataract surgeries, but when you use pattern deviation to strip away the effect of those cataracts, the difference in progression is even larger. We're talking a p-value of less than 0.001.
That is wild.
And because of that slower progression, the proportion of fast progressors, those losing worse than minus 0.5 decibels per year, was nearly halved. It dropped from 26% in the drops arm to just 15% in the SLT arm.
Dropping from 20 cents to 15 is just, that changes lives. And by year 6, 72% of the SLT patients still remained entirely drop-free.
Yeah, and the external validation here is what really grounds it for me. The progression rate of that drops arm perfectly matched a real-world UK cohort of 3,000 patients.
Right. So this isn't just some clinical trial anomaly. It is exactly what's happening in our clinics right now. But that actually brings us back to the central paradox we started with.
The IOP.
Yes, we are seeing undeniably superior protection of the visual field with SLT, but they achieve this with a similar IOP to the drops arm. We're talking 16.1 in the drops group versus 16.8 in the SLT group.
So SLT is protecting the nerve better with basically the same pressure.
Exactly. And my instinct points to 24-hour control. SLT doesn't forget to take itself at night. There are no adherence issues causing those silent IOP spikes.
Yeah, the 24-hour control and the shorter time to target IOP undoubtedly play a massive role.
Yeah.
But the authors also bring up the B-bond-to-B hypothesis.
Oh, right. The biomechanical overestimation or underestimation.
Exactly. The idea is that prostaglandin analogs, like the latanoprost used first line here, actually physically alter the cornea's biomechanics over time.
Making it thinner or more floppy, basically.
Right, and those changes might cause Goldmann applanation tonometry to systematically underestimate the true IOP.
So the similar IOP we're measuring might just be an illusion. The real IOP in the drops arm could actually be higher than what Goldmann is telling us.
Which connects perfectly to what we saw in the Horizon trial with the Hydrus microstent. Drop-independent IOP control, whether from SLT or MIGS, seems to offer superior visual field protection despite seemingly similar medicated IOPs.
That is fascinating. But, we do need to weigh the limitations here.
Of course.
First off, this is a post hoc analysis, and the statistical significance only really hit in the mild glaucoma subgroup. Also, the worse eye showed no difference, and we have 0 OCT data to back up the structural side. Plus, there are some investigator conflicts of interest to keep in mind.
Yeah, those are all really fair points to consider.
And let me play devil's advocate for a second. Before we completely rewrite our treatment algorithms based on this field data, let's look at the absolute numbers. A 30% slower progression sounds massive, right? But we are talking about a difference of 0.11 decibels per year. In a single patient sitting in front of you, factoring in normal visual field test retest variability, are you really going to notice 0.11 decibels?
In isolation, over a year or two, no, you absolutely wouldn't.
Right.
But you have to view this at scale. The difference becomes completely devastating when you look at the population level. Having your fast progressors from 26% to 15% means saving a massive amount of functional vision across your entire clinic over a decade.
That is a great point. It's about the cumulative impact. So,
Right.
look, if you are still automatically starting your newly diagnosed patients on latanoprost before considering SLT, this paper really demands a serious reconsideration.
It really does.
Yeah.
And honestly, it leaves us with a lingering paradox to confront on Monday morning. We measure the exact same IOP in two patients, but the one on drops progresses faster.
It makes you wonder what we're actually measuring.
Exactly. It forces us to ask, are our daily Goldmann measurements on prostaglandin patients fundamentally misleading us in the clinic?